Hey guys, welcome to Code Orbit. This is day two of our journey to Grandmaster in Codeforces, and today we'll be solving a problem called Domino Piling. So, in this problem, you are given a rectangular board of m cross n squares. Also, you are given an unlimited number of standard domino pieces, 2 into 1 squares. Domino, you can assume it like a pizza slice, and you are allowed to rotate the pieces. You are asked to place as many dominoes as possible on the board so as to meet the following conditions. So the condition number one is each domino completely covered two squares. Second is no two dominoes overlap. Third is each domino lies entirely inside the board. And the fourth, and it is allowed to touch the edges. Now we need to find the maximum number of dominoes which can be placed under these restrictions. In our input, we need to input two integers m and n, which are the both sizes in squares, where their ranges are 1 to 16, where m is less than or equal to n. And output, we just need to output one number that the maximum number of dominoes which can be placed. Now let me explain to you what the problem is. So here, let's suppose this is a rectangular board. So what m cross n means? So m is the number of rows, number of rows, like row 1 and row 2. So this uh, horizontal thing is called row here, and what n means, n is the number of columns. So yeah, here one, two, three, and it's number of columns. Okay. So here, what is this m cross n for this rectangular ball? It is 2 cross 3. Now, here we were given in the problem that domino piece takes 2 into 1 squares. Means it takes either two of the rows of the column section like this and this, or it can take this or this. Yeah. And how do we know that it only takes two into one of row or column? Because here it is said that you are allowed to rotate the pieces. Either you can, let's say, put it like this, or you can maybe put it like this. Yeah. And it will cover the whole actually. So now, what we need to observe is that here, let's say, we can take an example from here, like here 2 and 4. 2 are the number of rows and 4 are the columns. 1, 2, 3, and let's say one more, 4. Now, how many maximum can be placed? So let's say we place it column wise. So we can place one here, second one here, third one goes here, and fourth one here. You may just assume that it is covering the whole area completely. Yeah. One way is to place it like this. The other way is to place it row wise, like here. We will place one here, one here, one here, and the last one here. So in both the cases, you can see that the maximum number is equal to 4. You can only place 4 uh, in row wise and column wise. And so what do we, you know, get from this situation here is that whatever your rows and columns are like, say 2 and 4, these are 2 cross 4. So, and a single domino takes 2 squares. So our answer is always of 2 multiplied by 4 divided by 2, because the total number of square here you can see that two rows and four columns. So need to get total number of cells. So total cells is equal to 8. Let me erase all this. Total cells is 8. And how do we know it is 8? Because you can just count it here. 1, 2, 3, 4, 5, 6, 7, 8. You can take other example also, but it will always be of 2 into 4 is equal to 8. And since one block or one domino always takes two squares, so maximum number of dominoes we can put is 8 divided by 2. That is equal to 4. So you will say, what about the odd number of parts? Let's say we have 1, 2, and 3. 1, 2, and 3. So here total number of cells T, let's say, is 9. 3 into 3, right? Uh, 3 into 3 is equal to 9. And now, how can we do it? Because it is not an even number. So let's start placing. Let's say first we place here 1, then we can place here 2, then we can place here third one, 3. And you can see there are only 3 blocks left, so you can place only one here, or either you can choose the downside 2 blocks. So the total number you can place is 4. Now, what you can see is when we go our previous formula, that is 9 divided by 2, that gives you 4.5. But you can't place half of domino on the other block. So what you do is just remove this decimal part. So you get only 4. So how will we do it? Because in C++, integer data types always store complete value. So if you say int uh, is equal to 4.5, so it will always mean 4. Or you can say 4.9, that will always mean 4. So we don't need to worry about what it will do in case of odd. So yeah, it will always assign the integer type. So yeah, let's do our code here. So first we know that we have m and n, two variables, and we will take the input, let's say m here and n here. Now what we will do is simply you can just return. First you need to put the brackets so that these are performed or evaluated first. Multiplication of this and division by 2. Yes. So I think this will be enough. And yeah, guys, what you can do is just install this TPH Judge extension. Here, what I can do is just enter my input and add the expected output and just run a test case. And it will give me whether the test case is passing clearly or not. So let's just see. Here you can see it was okay. And what you can do is just come here, copy the input, go here, create a new test case, paste it, and the expected output can also be copied and just paste it. So now it is not feeling like it is very valuable, but whenever we do high level problems where input are very large, you can just do this and check through this. Now, what I can do is just go here, go to the submit option, yeah, and completely copy my code, paste it here, and just say submit. Okay, so yeah, it is asking some for verification or submit. So yeah, you can see that it is running and yeah, it is accepted. And you can also just check all your, once again, you can just also check all the test cases that have been here and all the test cases have been passed. So yeah, that was for today, guys. And if you like the video, definitely give a thumbs up. And if you have any doubts or comments, just drop it down in the comment section. And thank you and bye bye.